5, 4, 3, 2, 1.
I mean, everyone in front of the rocket, please.
I didn't really expect, all 1,600 kids to come in and, span 90 minutes. But, we handled it all right. I mean, it got a little hectic in there, and it's just something that we got to learn from tomorrow. We'll do a whole lot, more with, being organized tomorrow, trying to get them through. And, it also helps when you're dealing with a little bit older kids. So tomorrow should run a little bit more smooth. But, you just got to think on your feet. You got to do, as much as you can to keep things go smooth.
And timeout! 1 minute, 20 seconds left!
The big thing that's becoming clear right now is that it's not going to go as planned, and you need to have many layers of contingency plans for if something breaks, here's what to do. And so I'm sort of formulating those contingency plans as we go, and we'll see how they turn out and how they work out.
It's been a real challenge as the co-chair. My co-chair Jesse and I, we lead a group of 14 people, helping them do their parts, and so it's been a difficult process to not have your hands in everything. And I've had to learn how to delegate and how to trust, my team members to do what they need to do, and learn how to help them, but I can't do everybody's job. I can't put my hands in everything, otherwise I'd drown in it.
What's happening here is there's these things in your muscles called proprioceptors, and what's happening is when you're standing there, they sense your position, the positions of your legs. And so when you start leaning forward and they stretch, it senses that, and it sends a signal to your brain to compensate, to keep your balance, to make you fall back, or at least correct backwards. So what we're doing is we're stimulating those proprioceptors with just a vibration. And so when you're sitting there with your eyes closed, muscles relaxed, it makes you feel like you're falling forward and they're stretching. But really you're not, so you compensate and you end up falling backward.
You see, it just broke into 2 pieces. There's a piece right there. Okay, now what we're going to do, we're going to take this graham cracker, put it down into the liquid nitrogen. Now what we're going to do, this is a little more dangerous, so we'll take care of it, but we're going to chew on this, and it's going to be really cold in our mouths. So cold, in fact, that all of the water vapor in our breath will become frozen. And if you watch our faces, you can see the effect.
I actually didn't come into this position wanting to be the PR chair, but it turned out to be a great experience. I've learned how to deal with people, how to run my own committee, how to call people up and promote an event that I'm really excited about. I think that's been the greatest challenge, but also the greatest reward.
Go.
I just thought, this is so huge and so big, and I just knew I had to be a part of it. And I really wanted actually the challenge on a personal level of trying to put a program like this together. And I just saw the magnitude of it, and it was just seemed like such an incredible challenge. And so I went for it.
It's a project to make remote control for an iPod that uses motion instead of your fingers to control it. I got sick of walking around during winter and now always taking my gloves off, reaching my pocket, taking the iPod out, dialing it up, pushing the buttons. So I thought it'd be really great if I could just use motion, like waving my arm or tilting my head to control it instead of pushing buttons. So that led me to this, which is has a small sensor on it which detects motion, and then another chip which interprets it and sends a command to the iPod via its port on the top of it, where a remote control normally fits in. So this is what it would be like in real life. And then for the Expo, I mounted the same exact chip on a ping pong paddle, so it'd be easy to manipulate by people. And on the computer screen, it's showing what's going on the chip itself, as opposed to actually hooking up to the iPod. It's easier to see the logic behind it. On the left, there's a rectangle that represents the angle of tilt of the ping pong paddle, or the sensor on the ping pong paddle. In addition, the right shows the flow of the logic.
Just crack into pieces.
I can't even stretch it like it normally would. And if I warm it up for a second, it returns right back to its stretchy self.
This was a competition at our national conference, and the objective is to design a model plane or glider out of balsa wood, one sheet of balsa wood. This is the glider that we built after the conference, and we tested this in the Engineering Centers building, and it went around 80 feet.
I guess the role of indoor logistics is very challenging yet attractive, so I'd just like to take up the challenge and present my best to the campus.
Now, as this, you can see right here, there's actually liquid air. There's liquid oxygen that's sitting in there boiling, and room temperature. It's so cold.
This here is a hybrid rocket engine. Basically, a hybrid rocket engine is a combination of a solid rocket engine and a liquid rocket engine in the sense that it has both solid fuel and liquid fuel. For the case of this specific engine, because it's a demonstration engine, the solid fuel is an acrylic rod of plastic, and the liquid fuel is oxygen. What's going to happen is when we start this, a bit of propane through a glow plug is going to ignite in the ignition chamber up here. From there, high pressure oxygen will be flown down through a hole in the middle of the fuel rod, and at that higher temperature and pressure, the oxygen and acrylic will ignite and burn, producing thrust. So what we're going to do here, so we're just going to turn on the fuel. I need everyone in front of the rocket. Have to make sure things are safe. I need everyone in front of the rocket, please. Okay. This is going to be really loud, so you want to cover your ears.